Good morning. Today we will do the irregular geometry. Means the molecules having both lone pair as well as bond pair of electron around the central atom. So start with the first is the number of electron pair. Start with the number of electron pair 3. What is the regular geometry if the number of electron is 3? That is, we know that it's a trigonal planar like this. But now we have, say, 2 bond pair, 1 lone pair. Okay. So when there are 2 bond pair, 1 lone pair, then its formula become equal to AB2L. L stands for lone pair. So out of these 3, 1, 2 and 3, make this upper one lone pair. So you draw the structure like A, B, B. This is your L, represent as lone pair. So now this is a bent geometry, or it's V-shaped. Not consider this lone pair because there is no atom. So just the geometry is this. This is a V shape, or it's called bent. Okay. Then what is the example? Example in this is SO2, sulfur dioxide. Now see how to find the electron pair in sulfur dioxide. A valence electron in sulfur are 6 plus number of monovalent. There is no monovalent atom. Oxygen is attached to sulfur, so oxygen is divalent. Divalent means take it 0. So we get 3. So 3 electron pair, out of which we can see that SO2 there are 2 oxygen atom. It means bond pair are 2. And how to calculate lone pair? 3 minus 2 1. So this is a way we can draw the structure, but base of the structure is this regular geometry. We know that electron pair 3 means trigonal planar, but when we have a 2 bond pair and 1 lone pair, so lone pair occupy this position. Now what is the geometry of this SO2? Geometry of SO2 is trigonal planar, but its shape is bent or V shape. Both are different. Geometry depends upon electron pair. If the electron pairs are 3, geometry will be trigonal planar. Shape depends upon the lone pair and bond pair. Shape is bent or V shape. Okay, next. Next is we will start with a 4 electron pair. Electron pair 4. So in this category we have 3 molecules. First I will write methane, then we have ammonia, then we have water. Just draw the structure of these 3 molecules. So here is a central atom carbon, here is a central atom nitrogen, and here is a central atom oxygen. How to find the electron pair? Central atom carbon 4, monovalent 4 by 2 4. Central atom nitrogen having valence electron 5, monovalent 3 divided by 2 4. Again the central atom is oxygen, is valence electron 6 plus monovalent 2 divided by 2 is again 4. So these 3 molecules have a same number of electron pair. So all have a same geometry. Geometry of all molecule is tetrahedral. Okay. Now let's move. Next is bond pair. Here are 4. Lone pair is 0. There's 4 atoms. Here the bond pairs are 3. Lone pair is 1. Here the bond pairs 2, lone pair is 2. Sum of bond pair and lone pair equal to total electron pair. बॉन्ड पेयर हमें कहां से पता चल जाएंगे, जितने एटम उसके साथ अटैच हैं, दैट इज इक्वल टू बॉन्ड पेयर, यू कैन सी हियर. और लोन पेयर, टोटल इलेक्ट्रॉन पेयर माइनस बॉन्ड पेयर, that will give you lone pair. So this is regular geometry. You can draw the structure of methane as a tetrahedral like this. Its shape and geometry both are tetrahedral. Bond angle is 109 degree to 8 minutes. In ammonia, we have to make the 3 bond pair like this, and one position is occupied by the lone pair. So there are 2 types of repulsions. That here is a bond pair lone pair repulsion. Here is also bond pair lone pair repulsion. So bond angle that reduces to 107 degree. What is the shape of this molecule? Is pyramid or pyramidal कह सकते हैं. It's a pyramid, not like this. It's like this pyramid. 3 atoms are like this. Lone pair is here. Nothing is here, and it is a pyramid. Now next is water. We have a 2 bond pairs like this, and we have a 2 lone pairs to make it like this. So there are more stronger repulsions, as these 2 lone pair they repel each other. So there is lone pair repulsion. Here you can see is a lone pair bond pair repulsion. Here is also lone pair bond pair repulsion. लोन पे रिपल्शन ज्यादा होने की वजह से बॉन्ड एंगल फर्दर रिड्यूसेस टू 1 डिग्री, 104 डिग्री. You have to memorize these bonds. Again the geometry, forget about these lone pair. So geometry is again bent or V shape. So this is about the total number of electron pairs, 4, in which these possibilities are there. Next is electron pair 5. And when the electron pairs are 5, we know the geometry is trigonal, bipyramidal. Okay. So in this case we will take the example like PCl5, SF4, ClF3, which is central atom. First we will mark the central atom, then to find the electron pair, phosphorus, sulfur, chlorine. Find number of electron pair. Okay, in the first molecule, phosphorus has 5 valence electron, monovalent are 5, divided by 2 is 5. In the second, sulfur has valence electron 6, 4 monovalent, divided by 2 again 5. Chlorine has 7 valence electron, 3 monovalent, divided by 2 again 5. It means all these 3 molecules, they have the same geometry, trigonal bipyramidal, as number of electron pairs are same, 5 in each case. So what about bond pair? Here the bond pair are 5, lone pair is 0. So this is the regular geometry. Here the bond pairs are 4 and lone pair is 1. Here the bond pairs are 3 and lone pairs are 2. 5 minus 3, 2. So the structure of PCl5 we already know. 3 chlorines are in one plane and 2 chlorines are above the plane and below the plane. बॉन्ड एंगल इसमें था 120 डिग्री भी है, 3 बॉन्ड्स और 90 डिग्री भी है. There are 2 types of bonds in this molecule. These 3 bonds are called equatorial bond. Equatorial, I mean one plane. And these 2 bonds are called axial. Okay. E माने equatorial, A माने axial. So these now next move to SF6. Now there is one lone pair. So 2 possibilities are there. Either this lone pair will be on equatorial position or it will be on axial position. We will draw both the structures and then we will find which is more stable. So here you can see the lone pair is present at equatorial position. And in the second structure, you can see that lone pair is present on axial position. So make it big, like this. So these 2 structures are possible. Now how to decide where should be the lone pair, which is stable out of these 2? For that we will compare the repulsive forces at 90 degree. There is one lone pair, it means 2 type of repulsive forces are there. Lone pair, bond pair, and bond pair, bond pair. So this fluorine is at 90 degree of this lone pair. This fluorine is also at 90 degree of this, because these 3 are in one plane. These 3 are in one plane like this. So suppose fluorine is here, it is 90 of this, 90 of this, 90 of this. This fluorine is also 90 of this. So you can see there are 2 lone pair bond pair repulsions. One repulsion is here, second repulsion is here. 90 degree. Why 90 degree? Because we will choose 90, this is the minimum angle. In this case, lone pair bond pair repulsions are 3. You can see this is lone pair, this fluorine, and this fluorine, all are at 90 degree of the lone pair. तो ये भी इसके 90 पे है, ये भी इसके 90 पे है, ये भी इसके 90 पे है, तो इसकी रिपल्शंस हो गई 3. तो यहाँ पे इनको कंपेयर करने की जरूरत नहीं है, बिकॉज यहाँ पे देखिए ये रिपल्शंस हैं 2 और ये रिपल्शंस हैं 3. इसका मतलब है ये गलत हो गई. दिस इज आवर स्ट्रक्चर मोर स्टेबल, और इसकी ज्योमेट्री रहेगी ट्राइगोनल बाइपिरामिडल. तो इसकी जो शेप है वो हो जाती है सीसॉ. सीसॉ देखो, इसको भूल जाओ. ये इसका स्टैंड है, इसको ऐसे खड़ा करो तो ये ऐसे बन जाएगा. देखोगे लाइक दिस, यहाँ बैठो, यहाँ बैठो, तो दिस इज जस्ट लाइक अ सीसॉ. सो इट्स कॉल्ड सीसॉ. ओके, नेक्स्ट इज ClF3. In ClF3 we know there are 2 lone pairs. Geometry no doubt is trigonal bipyramidal, but there are 2 lone pairs, so 3 possibilities are there. Either both the lone pair they are on the equatorial position like this. This is the first possible structure. Both the lone pair they are at equatorial position. Second is that both the lone pair, they are at equatorial position, sorry, axial position. So here both are on equatorial, here both are on axial. Third possibility is one at axial, one at equatorial. These three structures are possible. Compare the stability. See, now we will compare, because there is two lone pairs, so one new type of repulsion is also there, that is a lone pair, lone pair. Second type of repulsion is lone pair, bond pair. So we will compare these two repulsions in every case and then ultimately find out which is more stable structure. Okay. So lone pair, lone pair, lone pair, bond pair. Let's find out. Now these two lone pairs, they are at 120 degree, we know that. Okay, these are at 120 degree. It means there is no lone pair at 90 degree. Keep in mind we are comparing at 90 degree angle. Okay, now here these two lone pair, they are at 180, it's very clear, they are at 180 degree, they are not at 90 degree, so at 90 degree there is no repulsion. Here you can see these two lone pair, they are at 90 degree, so here repulsion is 1. So up to this level we can decide that the structure number 3 is unstable, as it has one lone pair repulsion. So just cross it out. We are remaining with two structures. Okay, now compare lone pair, bond pair. See, this lone pair is at 90 degree of this. This F fluorine is 90 degree of these both, because this one plane. And this fluorine is also at 90 degree of these two. So there are total 4 repulsions, lone pair, bond pair. And here you can see this lone pair is at 90 degree of this, 90 degree of this, 90 degree of this. So there are 3 repulsions above and 3 repulsions below. So total 6 repulsions are there. So when you compare these two, there are 4 and there are 6. It means cross it out. We are with this structure, and this is the structure, actual structure of ClF3. Geometry is same, but what is the shape of this structure? Shape is, you can say, T shape. It is T shaped. But forget about these lone pair. This is forming a T, so this is T shape. Okay. And moving to 6. So in case of 6, the number of electron pairs 6, the geometry is, we know that, octahedral. So the structures are like SF6, BR, F5 and XE, F4. So mark the central atom as a sulfur, bromine, xenon. Find out the number of electron pair. Sulfur has valence 6, 6 plus 6 divided by 2, 6. Bromine has valence electron 7, it belongs to halogen, plus monovalent 5, again 6. Xenon belongs to noble gases, 8 plus 4 divided by 2, 6. So all the 3 molecules have 6 electron pairs, so all have same geometry, octahedral. Okay. So this is the octahedral geometry, and here will be your central atom. These 4, which is in rectangular form, they are in one plane, one above, one below. Okay. Now, so SF4, the same structure like this: 1 fluorine, 2 fluorine, 3 fluorine, 4 fluorine. So this form a square planar, and one above, next above. You can dot it like this, it become an octahedral. All the bond angles are of 90 degrees. It's a regular geometry. Now in this case, see, bond pairs are 6, but lone pair is 0. Regular geometry. But in this case, bond pairs are 5. You can see from here, and lone pair is 1. In this case, bond pair is 4 and lone pair 2. So when in octahedral we have a lone pair, if there is a one lone pair, don't disturb this this rectangular shape. Don't disturb this. If we have a one lone pair, put it anywhere, either above, in place of this fluorine, or in place of this fluorine. If there are two lone pair, one above, one below. Simple. Okay. Like in this case, so Br is at the center. 4 fluorines, they are at the corner of rectangle. So put lone pair here. This is distorted octahedral, or you can say, you can write it a distorted octahedral. Square pyramidal, you can also say it a square pyramidal. Do not need to memorize the bond angle. Okay. Now we have a xenon. It has a two lone pairs, so mark this rectangular fluorine as it is. Don't disturb this rectangular shape. Put one lone pair here, one lone pair here. It will be your square planar. So this is the shape of the HCF4. So this is about the 6. If you want to make a structure of 7, the last one, with this the Sepal model is complete. Okay, 7 electron pair. So here we have a IF7. Second structure is XEF6. Okay, find the number of electron pairs. Iodine 7 plus 7 by 2, 7. Xenon 8 plus 6 by 2 means 7. Both have a same geometry. What is the geometry of 7th? Is pentagonal. Pyramidal. This is the regular shape of regular geometry of 7 electron pair molecules. So here you can see bond pair are 7, lone pair is 0. So regular geometry is that put F fluorine in pentagon form, and they are in one plane at an angle of 72 degrees. One fluorine above, one fluorine below, 90 degrees. Regular geometry. Now, when there is one lone pair, you can see that bond pair are 6 and lone pair is 1. So just replace these equatorial, not with this. When you replace this with the lone pair, not replace this with the lone pair, because if you replace this with the lone pair, this lone pair become at 90 degrees of all the 5. Repulsions will be more. So you can write, you can draw one lone pair here. F, 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 F. These are in one plane. Now here are two strong repulsions. Like you can see, here is one fluorine and here is one fluorine. Distorted trigonal, pentagonal, bipyramidal. Here are two repulsions are there. 72 with this, 72 with this, 90 with this, and 90 with this. 4 repulsions are total. But if you put the lone pair here, there will be 5 repulsions at 90 degrees. So this is relatively more stable.